Good evening. Can everybody hear me? Okay. On behalf of William Penn University, I'd like to welcome you to this opening event in the Leaders Speak series. If you're expecting Lauren Abbas, I'm sorry to disappoint. I've been asked to introduce our primary speaker. I think it was 2 years ago or so. I was visiting my parents in Denver, Colorado, and my dad said, "Hey, you ought to go visit our neighbor. She's built an electric motorcycle, and she raced it at the Bonneville Salt Flats." So I walked over to the fence, and I heard him rummaging around in the garage, and I yelled over and said, "Hey, can I come over and talk?" And Eva said, "Sure." So I had a up close and personal of the disassembled, at the time, KillaJoule. The pictures that you see aren't what I saw. And I was at home this past summer, and I remember that Professor Watkins had asked for inputs on speakers earlier in the year, and I just happened to see Eva and her husband in the driveway, and went over and talked and asked if she would be interested in doing something like that. And she's like, "Oh, I love to speak to people and tell them all about what we're doing." And so then I contacted Dr. Hoeksema and Professor Wagner, and they jumped on it. And a few short months, here we are. Okay? Now, I usually don't have a problem getting up in front of people and talking, but this is particularly stressful for me because Eva is my parents' next door neighbor. If I really foul things up, my mother will hear about it tomorrow. And if she's got her computer connection, she'll hear about it right now because she's on the live stream. Eva got her doctorate in mechanical engineering last year from the University of Denver. Her doctoral dissertation was on galvanic corrosion of carbon aluminum composite systems. If you're not into corrosion, you might not have a lot of appeal. But in her spare time, 5 years from the first weld until a world land speed record on the KillaJoule, it's my pleasure to introduce Eva Håkansson.
Well, thank you so much for that introduction, and thank you everybody for coming. It's great to see that we even had to get more chairs. I love that. Thank you for coming here instead of watching the homecoming parade. I heard that that is a competing event today. So the title of my presentation pretty much tells you what I'm going to talk about: world speed records and 3D printed motorcycles, why scientists and engineers are superheroes. But first, I want to say a few words about why I became an engineer in the first place. So I'm a mechanical engineer, and I became an engineer because of two main reasons. I wanted things I couldn't afford. About 10 years ago, I wanted an electric car. There wasn't much to choose from, and they were insanely expensive. So my dad suggested, "Why don't you build an electric motorcycle instead? I will help you and show you how." And at that point, I realized I need to become an engineer because I wanted to build things that I can't afford, or I wanted to build things that simply didn't exist. My first little motorcycle was fairly wimpy, highway speed, but nothing more. But I wanted the world's fastest electric motorcycle. And then also, I wanted to save the world. So I'm a tree hugger at heart, and I'm a speed junkie. And in the intersection there between electric racing is a great way of promoting eco-friendly technology. So that's why I decided to become an engineer, despite I actually had my bachelor degree in business. So about not being able to afford things, I guess that's something we struggle with, all of us. We want fancy things, we can't afford it. Well, I don't have a very girly hobby, but I'm girly in some extent, and I love expensive handbags. And I been drooling on these Chanel handbags for I don't know how many decades, but $4,000 is simply not what I can spend on a handbag. But being an engineer, well, what do? Well, I CAD'd up my own handbag and 3D printed it. So all of it, 3D printed, the rubber, everything, and I think it's way cooler than the Chanel handbag, and it definitely gets me more comments and many fewer dirty looks that what a snob she is. It's more like, ooh, that's cool, can I get the file? I want to print my own. So those are things you can do when you're an engineer and know how to build things. In comic books, superheroes save the world. But in real life, engineers and scientists will save the world. And in one area where scientists and engineers will really hold the key to a sustainable future is in transportation. I mean, we all like to have our own cars, but driving around burning fuel in the city is wasteful and not sustainable. And electric cars is really the way to go for any kind of urban transportation. I often get the question, is electrics the future? No. Electric cars is the present. I drive an electric car myself. This is a Nissan Leaf, the best car I've ever had. I'm quite sure a Tesla will be an even better car, but my budget isn't extending that far right now. So electrics is the future for transportation. It's here to stay, for sure. Electric cars is also a perfect match if you happen to do what I did, or me and my husband did. We bought solar cells. So we're making our own fuel quote, for our car. We're making our own electricity, and we drive for free. I'm zipping around town quietly, pollution-free, and for free. I mean, it can't get any better than that. I call that a perfect match. Despite that, actually, I can just give you a number. So you can pick up a used Nissan Leaf electric car for about $10,000. You can pick up a solar array suitable for feeding that car with electricity for about $10,000. So $20,000 altogether, you have a package with a car that you never have to put gas in. You can drive it for free. I mean, that's just a no-brainer. We just had to do it. Despite being such a perfect match and such a no-brainer, I was shocked when I saw this recent survey. This is from last year. 60% of US consumers said they didn't know you could buy an electric car. And 80% had never taken a ride in an electric car. I could believe that, but I just couldn't believe that so few people knew about this perfect solution for urban transportation. And that really shows me that my decision to build an insanely fast electric motorcycle to promote electric vehicles was the right decision. So the KillaJoule, which is the name of my motorcycle, it is technically a motorcycle, even if it looks more like a car. I can send around a model. Here's a scale model. The real deal is 19 feet long. But there you can get a feel for what it really looks like. So it was built with the sole purpose of demonstrating the capability of electric vehicles. So that is the tree hugger in me, trying to do something for the planet, and built to change the perception of electric vehicles. And in addition to setting world records, I also do things that are kind of unusual for an engineer. Mother Nature gave me some assets, and if that gets my posts shared more frequently on social media, well, I will use it. I will show that the electric vehicles are sexy. That is not my typical workshop outfit. But it certainly gets you clicks and shares. And I even invented a term for this. I call this eco-activism in disguise. So what I am doing is nothing different than an activist climbing a whale hunting vessel with a Greenpeace banner. I just do it in a different way. We all try to change the planet. I very much admire activists that do things like that, but I didn't like the prospect of being arrested. That just wasn't my thing. So I tried to figure out the way of doing activism kind of disguised. So that's what I do. It's for the gearheads. They're looking at me. I'm just running a racing program. But in reality, I'm really promoting eco-friendly technology. And at 270 miles per hour, you get a lot of attention, particularly in a suit like that. I didn't wear the suit at 270 miles per hour, okay. So I said the KillaJoule was built to show that electric vehicles can be insanely fast. And I actually built about 80% of it myself. So I say that 80% of the blood, sweat, tears, and hours are mine. And it's built in my backyard garage. And there are just a few pictures from the last 7 years. That's the first test ride, spring break 2010. Lots of hours of machining, wiring. So lots of wiring in an electric vehicle. And there it looks a bit more like it does now. Welding, that's my superhero moment. I just love the feeling of fusing metal. I think that's the coolest thing ever. And this is my headquarters, the 2-car garage behind my house. So I am not particularly rich, particularly not after building a vehicle like this, but I didn't start out rich either. My husband is a research scientist and engineer working at NOAA, building scientific instruments for air quality measurements, and he brings home an ordinary government salary, and I, until recently, brought home an ordinary graduate stipend. But putting our brains together and our limited resources, you can do a lot of things if you work cleverly and find that little niche where you can do something special. So I said, well, that's my teammate, and I also have the great pleasure of marrying my teammate and my fellow engineer. That's my best decision ever, for sure. So what is this KillaJoule? Well, you see the model going around here. It looks almost like a fish with a wing hanging out on one side. It is technically a motorcycle. How a motorcycle is defined is that a motorcycle has to have 3 wheels or less. 2 of those needs to be in line. It has to drive on the rear, steer on the front. And if you have a 3rd wheel that's offset, doesn't drive or doesn't steer, that makes it a sidecar motorcycle. So, of course, this motorcycle has as much in common with regular motorcycles as a Formula 1 car has in common with your family van. Basically nothing. It's purebred for racing. It does steer, but not much. However, it has reverse. So the electric motor doesn't care which direction it goes. I just flip a switch, and it will go almost as fast in reverse as it would forward. I've never tried that. Would be an exciting ride. So it holds the record for the fastest electric motorcycle in the world. The official record is 248 miles per hour. There are lots of technicalities for how you set records. You have to have winds correct, international inspectors, you have to do it in opposite directions, and so on. So the official record is a bit lower than its recorded top speed, which is 270 miles per hour. It has also made me officially the world's fastest female on a motorcycle, or actually in this case, in a motorcycle. Because in a motorcycle like this, you sit inside. And it's built to fit me, so if you're much more than 5'2", you will not fit, sorry. So, how do you run such a thing for records, and what does it look like? Well, I have a little video, it's about 2.5 minutes long, from the Bonneville Salt Flats last year. So this year, we were out last month, hoping to set a new record, but Mother Nature was against us. It was insanely hot. It was over 105 degrees every day. You could literally fry an egg on the bodywork of the motorcycle. And already the first day we had electronics break because of the heat, and we were fighting that all week. So we only got to 244 miles per hour, which was not a new record. But it was the fastest speed recorded of all attending motorcycles. So the video I will show is from last year, and the record we set to 248 back then. And this is from this Bonneville Salt Flats in Utah, which is the place, the most popular place to run for speed records. Let me see if we can get this to work. definition to show that electric vehicles doesn't mean that something has to be slow or a sacrifice of the joy of driving or riding.
This is how I earn my keep.
I have the same mindset, the same goal as people climbing nuclear cooling towers with Greenpeace banners. I'm just doing it a different way. For short duration racing, and we're talking about 10 minutes or less, electric drivetrains are absolutely unbeatable. So that's kind of a typical racing at the Bonneville Salt Flats. So if you, anybody can actually run for the records at the Bonneville Salt Flats. You have to follow quite a bit of safety rules, but there are class rules for almost any kind of imaginable vehicles. All these events are public events, and you just pay an entry fee. You go there, you go through a technical inspection, and if you pass that, you can run for world records. And it's typically about 5 days, and people ask me, most people think it's my favorite part to be out racing, and I'm always disappointed when I said it's just miserable. It's 5 days of like taking a final exam. You work from sun goes up to sun goes down, and when sun goes down, then you do analyze data, you write blog posts, Facebook updates, sponsor updates, and then you sleep for a few hours, and then you repeat it. And it's typically really hot and really stressful. But it's worth it. I mean, it's kind of like, none of us like the final exam on the class, but if you didn't take the final exam, it wouldn't really be worth taking the class at all. So it's a mixed feeling about being out racing. But when everything works, it's just like magic. So driving that fast, so 250 plus miles per hour, I would say it's a mixture of boredom, horror, and magic. So getting up to speed, it accelerates like a family van. It's just, there's nothing really happening. But it just continues up to 250 miles per hour with the same kind of acceleration. When I exceed the speed I've done before, then you're in uncharted territory. The bike has never gone this fast. I have never gone this fast. I have no clue what's going to happen. Is it going to take off? Is the wheel going to fall off? And that's kind of the moments of horror. And when everything works, it's just magic. And then it's like, let's do this again. Let's build something faster. So, but my favorite part is really building. And that's where I get my greatest enjoyment, is to build something that has never been built before. So what is inside the KillaJoule? Well, in concept, electric vehicles are really, really simple. I call this a giant cordless drill with wheels. It's really what it is. Instead of a 1 pound battery, it has a 350 pound battery, 400 volts, 400 horsepower, motor, some power electronics, a throttle, and that's it. Then, of course, to get such a vehicle to work reliably, go straight, and hold together is a whole different story. But in concept, electric vehicles are really, really simple. If you're interested in all the technical details, I have a few postcards by the coffee. Looks something along this line, but it doesn't have my notes on the back. It has the data on the back. So that picture are on the postcards if you're interested. Also, all the information is on my website. So, setting records is always about going faster. Faster than last year, faster than before, faster than ever. So how do you make a cordless drill go faster? Well, you can do two things. You can add horsepower, but horsepower is expensive. And there is simply not any more room in the bike to get a bigger battery, bigger motor, bigger electronics. So the other way you can go, you can decrease air resistance, because at this speed, it's all about air resistance. It's not about horsepower to weight ratio, it's horsepower to drag ratio. That's what makes you go fast. If you look at this sidecar, you don't have to be an aerodynamics expert to see that that is not particularly good. It's stuff sticking out in the air, it doesn't seem particularly aerodynamic. And if you take off the top plate, it's even worse. It was this ugly. It was this ugly. I call this the Christmas gift. It's actually sheet metal that's folded around like you fold a Christmas gift. It was done last evening, several years ago. It worked. We didn't change it. But a couple of years ago, it was time to change things. This had to go, and something more aerodynamic had to get in place because I didn't have any more horsepower and I wanted to go faster. So we spent all winter between 2015 and 2016, built a beautiful sidecar skin, built like an airplane wing with ribs, sheet metal, rivets, all of that. Looked gorgeous. What was the result? Well, it was super slick from an aerodynamic perspective. It took 33% less energy to go through the air, but it didn't have enough downforce. So we didn't realize how much we were depending on downforce. Downforce is, an airplane wing creates lift and lifts the airplane up. Well, you take an airplane wing and you turn it upside down and you get downforce. All the race cars have that with spoilers and wings. And our old sidecar had downforce, and we didn't realize how critical that was. So this new wing was beautiful, super slick through the air, but the whole bike was just sliding around, and at 250 miles per hour, that's fairly scary. And I was not a happy camper after that run. I said, we can't do this. We have to go home. We have to fix this. I'm just sliding around. I give throttle. It goes one way. I get let off the throttle, and the bike goes the other way. In fact, really the first time I've been somewhat scared driving it. So we had to go home and figure out what to do. We had built this gorgeous sheet metal thing. We couldn't change it out in the track. We needed a way of making multiple skins so we could tune in and pick the right downforce. Because if it's a year where the salt is wet, it's slippery and you need a lot of force. But a lot of downforce causes aerodynamic drag. If it was a year where it was dry and hard surface, we could have less downforce and therefore go faster and still get grip. So what was the solution? 3D printing. So you already realized that I like 3D printing. The scale model that's being sent around is 3D printed. My purse is 3D printed. And we had a 3D printer. Here's a little one. It's actually printing an early version of that handbag right there in the picture. But we couldn't make a piece that is this big on a printer that's this big. So we looked at this printer as a Ludspot, and we liked it a lot, and it happened to be an open hardware and open source printer. So you can get all the drawings, all the firmware, all the software, everything online. And we looked at this and said, we can build a giant one. That is just a winter's engineering project. So over the winter, we put our brains together and we built a giant 3D printer. Prints about a cubic yard. And that's a 6-day print, about 30 pounds, and that's a new sidecar skin. But it's not 6 days I have to sit there and watch. It's just start it up, and 6 days later I have a part. Much easier than spending 3 months building something out of sheet metal. And there it is. There's one installed on the bike, another one I'm holding in my hands. And the good thing with this design was that the top could be almost flat. So it's made out of sheet metal, and then all the aerodynamic shape is on the bottom. And that sheet metal top also was a perfect place to put all the names of people that have helped in one way or another. Even if I put in 80% of the blood, sweat, and tears, there are lots of people that have helped in one way or another. Just such a simple thing of sending me nice pictures from the track, because I can't take pictures of myself when I'm racing. So I'm relying on someone else. Doing things like that, you get your name there. Also, actually, Professor Christopher's parents are in there, because they don't complain when I'm grinding things on the driveway late night. and that's more important than you can imagine. It's having great neighbors is a must when you do weird things in your garage in a residential area, because your neighbors can really make things difficult or almost impossible if they aren't good. So we also experimented with other things, being 3D printing nerds. We 3D printed a wheel. So this is an aluminum wheel with a 3D printed rubber tread. Nothing has ever seen the light of day before of that kind. We had, well, I'll get to that, how that worked out. And this is one of the things I'm most excited about, is this wheel, because this has potential to go really, really, really fast. And there it is when it's fully assembled back again. So we took the bike out to Bonneville Salt Flats last month, and this is what it looked like. It was a pretty good year, except it was insanely hot. So did things work? Yes and no. The new sidecar worked perfectly. It worked so good that at day 3, Bill and I looked at each other and said, we haven't even discussed this sidecar. It worked so good we didn't even notice it. It just worked flawlessly. It didn't get soft in the sun. It just did its job silently, and we were super happy. The 3D printed wheel needs a little bit more work. Concept is good, but we ran out of time and it wasn't executed perfectly. So what was the result? Well, I already mentioned that. At extreme heat, and also we had really rough salt. It was like a washboard, but because it was so hot and dry, they couldn't even it out. So we only got to 244 miles per hour. It wasn't really what I wanted, but it's what you get. So what's now? Well, I've worked for 7 years on the same project, and it's time for something new. And you've already heard that I am moving to New Zealand to teach engineering design at the University of Auckland. And that's a job I got simply because of this cool hobby project. So I want to emphasize that the KillaJoule had really nothing to do with my studies. It was completely in spare time, spare money. And the university wasn't really interested. I'm not really sure why. They never saw the value in it. So it had nothing to do with my studies. My title of my dissertation was mentioned here, Galvanic Corrosion of Aluminum Carbon Composite Systems. Galvanic corrosion is when one material eats another. For example, carbon fiber can eat aluminum in the presence of water. It's a super big problem on airplanes and sports cars, and also, in my case, on power lines that were supported with carbon fiber composite rods. What is kind of coincidental is, in my life, is that batteries is one of the very few beneficial uses of galvanic corrosion. What's happening inside the battery is the same. You have two materials reacting with each other, and one kind of eats the other one and produces electricity, but you can reverse it by charging the battery again. In galvanic corrosion, you cannot. So my work with batteries really helped my galvanic corrosion work. My galvanic corrosion work helped me better understand batteries. Anyway, I'm moving to New Zealand. I got a really cool job because of my cool project. University of Auckland is a huge school. I don't even know how many students they have, but the incoming freshman engineering class is 1,000 students. That's as big as your university. And I have 2 sections, so 500 students in each class to teach. And that's a bit intimidating, but I think it will be fun. And then, of course, we can't stop racing just because we're moving. We're building a new bike. So the KillaJoule is getting old. I think it's too slow. It doesn't seem to go much faster than 250, 270 miles per hour. So we're building a new one, nicknamed Green Envy, because it will be an enviable vehicle, and it will have at least 1,000 horsepower. We will use everything we have learned. There will be a lot of 3D printing, rather than composites for body work. We're hoping to 3D print the nose and other complex shaped parts. I might add, the KillaJoule has the nose, canopy, and sidecar wheel cover composites. The rest is just aluminum sheet metal. It's just painted to match. And I see the Green Envy in something similar, but with 3D printing instead of composites. And the goal is to race in Australia 2019. So Australia has also salt flats, and people are considering the salt quality better in Australia than in Utah, but the elevation is lower. What has the elevation had to do with racing, you may think? A lot. So the higher up you are, the thinner the air is. An electric vehicle doesn't breathe. It doesn't consume oxygen. The best thing would be if I could run in vacuum. That would be the absolutely fine. Like the Hyperloop. If I can run in a Hyperloop tunnel, that would be great. So if you go down in elevation, Utah is pretty high, 5,000, 4,000 feet or so. And Australia is much lower, so that will slow us down, but we just have to work around that with more horsepower. but it's closer to New Zealand, so that's kind of the #1 choice for racing. So what's the goals for Green Envy? So I said early on my goal was to build the world's fastest electric motorcycle. Well, I've accomplished that goal, so that's kind of checked off. And I believe you always need to have goals. That's how you make progress in life and how you get through rough spots when you feel like you take 1 step forwards and 2 steps backwards. You need a goal, and the goal for Green Envy is to become the world's fastest motorcycle, period. So the current record is 376 miles per hour in a motorcycle, similarly looking thing, but with 2 wheels only. And if I can accomplish that, it would be fairly historic, and that would really show that electric vehicles are not slow or boring. And that's really what my mission is. So to tie things together, I started out by saying that scientists and engineers are real-life superheroes. And that, supposed to comic books where superheroes save the world, engineers and scientists will save the real world. So why are we superheroes? Well, we can create things that have never been created before. We don't need superpowers, really, to shape metal or cure diseases. And we definitely hold the key to a sustainable future. And the last line, that's really why I love being an engineer, because I see that we can do something good. Of course, I need to mention if there are superheroes, there's supervillains. And I'm hoping by going into engineering teaching that I can avoid creating supervillains and actually create superheroes that use their skills to something good that will benefit mankind. So, well, I love being an engineer, which is also kind of a scientist, and I hope that, I didn't ask how many engineers or scientists here, but I'm feeling there are quite a few. Even if you're not in engineering or science, you can be a superhero in your own field. I only see my little field, of course, because that's the world I live in. But if you know engineers, you know scientists, you have them in your family or you one yourself, try to use your superheroes to make this world a better place. That's my message. Thank you. And I'm happy to take questions, because we have quite a bit of time, I believe, in the schedule. And you do need to use the microphone so they will get it in the live feed. So go ahead.
Okay, I had a question on the way you designed the actual, I term the fuselage assembly of the motorcycle. Did you use did you run it through did you make a mock-up and then run it through a wind tunnel to simulate the dynamics, the forces acting on it and so forth?
So the KillaJoule has never been in an actual wind tunnel. The reason for that is simply time and budget. So the closest suitable wind tunnel is in Salt Lake City, which is about a 12-hour drive from my house. But I've had it in virtual wind tunnels, so computational fluid dynamics. And also, if you look at this little scale model from top, you can see that it kind of looks like a wing. So the whole overall shape is an airfoil, which follows a mathematical model for a known low aerodynamic drag. The nose is also an airfoil, but in the other side. I haven't done as much simulation work as I wish I had, but it's because I'm working on a low budget production and limited resources. The next one, the Green Envy, will hopefully have a much better aerodynamic shape, and also we will do a much better job on the simulation and modeling of it. But I have resources now that I didn't have, and knowledge, of course, that I didn't have 7 years ago when we started. But you are right on target that at this speed, it's all about aerodynamics. Nothing else matters more. Actually, well, one thing matters more, and that's reliability. I have a saying that my crew is so tired of hearing that they cringe every time I say it. but it's still valid, and is to finish first, one must first finish. And there are lots of people building beautiful things that are so complicated that it will never even get to the starting line. So the success really, for the KillaJoule success is really on reliability. It has run every year, and it has had very little problem compared to other vehicles of the same kind. You need a microphone. There you go. Thank you.
Short follow-up question. On the actual structural elements in the building design, did you use the aircraft technology that you would use, let's say, to build a supersonic aircraft as your model?
So answer is yes and no. So we actually use a lot of aircraft technology. So my husband he's a private pilot, always loved aviation. He also works for the National Oceanic and Atmospheric Administration. He builds scientific instruments that go on airplanes. So he goes through the whole certification process with the FAA to get things approved for use on airplanes. And I'm getting my private pilot license right now. And so we're kind of into the aviation community. And when I met my husband, he was building an airplane, an experimental aircraft himself, and had all the tools. He decided that land speed racing was more interesting, and he sold his half-built airplane. But we kept all the tools, and we kept the kind of the mindset. So we actually use a lot of aircraft stuff. So the KillaJoule has a steel frame. That's the main structure. And that is aircraft quality steel tubing, 4130 chrome moly to be exact, is the alloy. The skin is aluminum and manufactured with aircraft methods, so it's riveted with ribs and aluminum rivets. Another thing we did, which I had to give my husband credit for pushing, was everything we use in wiring, connectors, etc. is aircraft quality. So it's aircraft quality wires, aircraft quality switches, and that turned out to be a great thing because the salt is incredibly corrosive. That was one thing we didn't realize when we started, how destructive that would be to everything. And the fact that we used high quality wiring, connectors, and protect everything like you would in an airplane, made it actually incredibly reliable. So it's, I sometimes jokingly call it's my airplane with one wing. I think it's true in many aspects. It looks like an airplane, it costs about as much as an airplane, and it's built with aircraft quality things. But there's a lot of things you can learn from the aircraft community, the aviation community. They are darn good at building things that last and that are reliable. So there's another tip to students here if you want to go into projects. Pick quality components. Don't skimp on the materials.
So my 6-year-old daughter Sophie here has a question about how you made the 3D printer, the big 3D printer, and probably if you used a little 3D printer to print parts, or how did that, could you tell me more about the story of how building that came about?
Sure. Well, 3D printers actually can make 3D printers. I think that's almost creepy. The 3D printer I have, what I started with, I can just go back to it, is actually built to a big extent using 3D printers. So this printer was built about an hour north of Denver in Loveland, and they have a whole hatchery. They have 150 printers in a big room making other 3D printers. So lots of the parts, except for the uprights, that's just aluminum, but all the corners and little pieces, print heads, gears, all of that is 3D printed. So we thought we will do the same thing. So we actually used this little printer to print the parts for the big printer. And the big printer is kind of hard to see, but you can see it's the same concept. All of these parts you see here, cases, holders, all of that is 3D printed corners.
Is it really as tall as you?
Pardon?
Is it really as tall as you?
Well, it's sitting on the, it's sitting on a base that's about that tall. But the print volume is about a cubic yard. We have the parts to build another one that's even bigger. So this was kind of the first prototype. So the way you go about to build your own 3D printer, we used this commercial printer, the Lunchbot TES 5 as our inspiration. It's an open hardware and open source printer, which means that everything about it is published. Actually, when you buy one of these printers, they give you an SD card with spare parts. It has all the files, all the information to build your own spare parts. If you're clever, you start by building spare parts before you need a spare part. And when your printer is broken, you have to borrow your friend's printer to print your spare parts. So they publish everything, so we just use the firmware, the source code, and then scaled it up. So you can build your own 3D printer if you want. But maybe you want to start by just buying a little commercial printer, because it's quite a bit of work.
I'm just curious, why salt flats? Why do you race on those instead of some other surface or whatever?
So the question is, why do you race at the salt flats? So one of the problems you have if you want to go really, really, really fast, we're talking 300, 400, 500 miles per hour, is that you need a lot of room to accelerate. And there simply are no racetracks in the world long enough. So for me to get up to 300 miles per hour, I need about 4 miles to get up to that speed. And the only place you can find that's big and flat and that would allow you to set up a motorsport event are the salt flats. There are a few more places. There's Dry Lake in California. There's salt flats in Australia. But you kind of end up in these places where no one else wants to be. Salt is not an optimal surface at all. It's actually kind of slippery. It's like a dirt road. And that fact makes it that you have to actually need even more room, because you can only accelerate slowly. Otherwise, your wheel just breaks loose. That's why we put so much effort into downforce, because when the surface is so loose, you have to push your vehicle into the surface to get any grip at all with your wheel. So it's just a matter of room. I mean, if someone wants to spend $10 million of paving a 15-mile strip somewhere out in the middle of nowhere, I would be happy to run there. But I don't have that budget. So a normal airfield is not long enough for these kinds of vehicles. More questions? We have a question there. Oh, there's a microphone coming, great.
So how do you anticipate making use of these experiences with building and racing in your teaching?
So how do I think I can use this as my teaching? Well, first off, I got the teaching job for doing this, so that's kind of number one, checked. I'm not quite sure yet. So I have a few months left before the semester starts in March. So I don't know yet. I really don't have a good answer. I'm hoping to get it in somehow, but I'm not quite sure yet. I think maybe one thing I always want to show, and that's what I've tried to show here during the day, been meeting classes today, is that you can do a lot with limited resources if you really just put your heart and mind into it. You don't need $1 million budgets if you just work cleverly and find your little niche where you can leave a mark.
I feel like my question, it's an answer I should know, but I don't know. Can you explain to me the name KillaJoule, like where that came from and what that means?
So the kilojoule is a play on words. So the metric unit for kilocalories are kilojoules or megajoules. So it's just kind of a play on a hardcore version of the kilojoule become kilojoule. It's a unique word that makes it so you can Google it easily. It should have been kilojoule, like in jewelry. But it turned out that name was taken by a female DJ and the domain was taken. So I had to change my mind and say, okay, let's do joule as in energy instead. It's also because my husband had a drag racing motorcycle named KillaJoule that actually about 10 years ago was the world's fastest electric motorcycle and still is the world's quickest electric motorcycle. It does 0 to 60 in less than 1 second. So it was just kind of, we thought we would keep the Killa name and they'd be kind of like sisters, but the reality was more that people were confused because the names were so similar. So for the next bike, we're going with a completely different name, just to have no confusion.
And one more question. When you're racing, how many others are there racing with you? Do you have competitors when you're racing at the flats?
So at an event at the Bonneville Salt Flats, you don't really have competitors. You're all running for records, but there could be 200 entrants, and they're running for 200 different records. It's the 50cc turbocharged vintage motorcycle with no fairing. That's the class. In my specific class, which is electrically powered streamliner motorcycle with a sidecar over 300 kilogram, my vehicle is the only one that's ever been in that class. But I'm not so interested in particular class records. I'm interested in the overall records. So the KillaJoule is the world's fastest electric motorcycle, no matter what classes. The next one is at 215 miles per hour, is number 2. So I'm with a huge margin. It's a whole different class. But for overall records, people don't care so much about classes. For the absolute overall motorcycle records, that bike, of course, runs in a completely different class because it's internal combustion. But we're all after the outright record, and that's independent of classes. So you can also add, when you run for records, you're alone on the track, as you saw. There's no shoulder-to-shoulder competition. When it's your turn, and you just do your thing and you run against the clock. And when you're done, you turn off and the next person goes. So it's a whole different kind of racing and competing. When you run for record, you run against everybody else in history. You're not running against the people that are there on the starting line that day. You're running against everybody that's ever been out there. So I think that's really much more exciting, because when you set the record, you're truly the fastest, not just the fastest that day. More questions? There we go.
About 12 years ago, I asked this question of a Chrysler executive that I knew, and I wasn't happy with his answer, and I don't know if I'll be happy with your answer, but I'll give it a shot. Okay? In the 1960s, we sent men to the moon with hydrogen fuel cells. Why are we still messing around with internal combustion?
Oh, that's an interesting question. I've never heard it phrased that way. So the reason we're still messing around with internal combustion is completely not related to fuel cells at all. So the reason we have internal combustion is that batteries in electric cars are still kind of in an infancy. So what made electric cars really possible for consumer use are the lithium-ion batteries. Lithium-ion batteries came about 10 to 20 years ago, was the breakthrough when we wanted mobile electronics. We wanted cell phones, Walkmans, and so on. And that drove the battery technology because you couldn't, the first cell phones had lead-acid batteries and they came in their own bag because you just didn't have the battery technology. So mobile technology really pushed battery technology. And about 10 years ago, battery technology became good enough to actually make a practical electric car that you would want with a long-lasting battery and long range. But electric cars are still kind of in infancy. Lots have happened in the last 5 years. And the replacement for the internal combustion will be electric drive. The reason it will not be fuel cells will be strictly scientific. If you look at the total, we call it well-to-wheel efficiency, so the energy you extract out of whatever, the ground, the sun, the wind, and the whole chain until that makes your wheels turn. If you look at that whole chain for an electric car, you are somewhere between 60 and 80% efficiency. So 60 to 80% of what you extracted out from whatever source actually makes you go to work. If you look at that chain for an internal combustion engine, that number is about 15%, 1.5. It's insanely wasteful. If you look at that chain for hydrogen fuel cell, you're about the same range, 15%. You have to make, so hydrogen doesn't exist in nature. It's not like fossil fuels like gasoline, which you just cook out of crude oil and you get gasoline or diesel. Hydrogen has to be made either from natural gas, where you extract the hydrogen, or you have to make it from electrolysis of water by using electricity. So it's not the primary energy source. Hydrogen is an energy carrier. I typically say that the hydrogen fuel cell with its tank of hydrogen is a crappy battery. It's a really, really inefficient battery, because you put electricity in, you make hydrogen, and then you take the hydrogen, store that, and you take the hydrogen out, you put it in your fuel cell and make electricity again. Why not just take your electricity and charge a battery and then drive away? And you don't need this $1 million unit in the middle that's fairly inefficient. So, and saying so, I'm probably going to get comments on Facebook or whatever now saying that that's not true. They will look at these innovations recent in lab and you have such and such energy efficiency. But what is commercially available now, the best stuff you can buy is much worse than an electric car. So why go that route? I received this question actually about 10 years ago at a seminar. And I said back then, and I'm going to say the same thing now, the only thing that could change my answer in that question will be if we are successful in making a fuel cell that actually makes electricity from a liquid fuel directly. So there are fuel cells you can feed with methanol, but they don't last long and they have poor efficiency. But if you could do that and get that to work, then I can see that's a replacement for the internal combustion engine, because then you can fill in a liquid fuel and drive an electricity. But the technology isn't there. So, yeah, my answer 10 years ago was we will never see fuel cell cars as a mainstream solution, and my answer today is we will never see fuel cell cars as a mainstream solution.
Without superheroes.
I think we need some true superpowers. But again, if I was a car manufacturer, I would certainly keep a little department working on it, because I don't want to put all my eggs in the same basket, and someone may come up with that magic invention that actually makes it possible, something that we haven't seen before. But I wouldn't bet on it, wouldn't bet my farm on fuel cells. Okay. More questions?
Have you any experience with hydrogen peroxide power systems? I'll bring up something that you may, if you've explored that, you may or may not be aware of. There are people in the world right now who are using. There's a Mexican scientist who has a system. In addition, going back historically, they claim I haven't seen. I've just done some rough reading on it. They claim that German engineers actually, in the late 1930s and 1940s, developed hydrogen peroxide engines for U-boats and marine application, and they brought one or two to the U.S. to a naval research facility post-World War II, and the scientists there were never able to replicate the work that the German scientists and engineers had done.
Okay, so this is an interesting question, and I'm not familiar with everything you're mentioning. Hydrogen peroxide is just like hydrogen, an energy carrier, maybe in best case. In other cases, it's just an oxygen carrier is what it is. I have never experienced hydrogen peroxide myself. There is kind of one part of the racing community that builds rocket vehicles that use hydrogen peroxide and a catalyst to make steam. I was at the ice racing in Sweden this winter, and there was a hydrogen peroxide powered sled that was attempting a 200 mile per hour or something record using that. The classic rocket belts are also hydrogen peroxide powered. Again, nothing that I've dealt with, and I'm sticking to electrics. You mentioned submarines. I'm not familiar with exactly what you mentioned, but my dad actually designed the Stirling engine that is in the Swedish submarines. That's his design. It's a V4 Stirling engine, and it runs on diesel fuel and hydrogen peroxide. So the Stirling engine is an external combustion engine, so it doesn't have a flame inside a cylinder. It has a flame outside, and then you lead the heat into the heat engine. The problem you have when you're underwater, there's no oxygen you can use for your engine. So instead you use hydrogen peroxide as your oxygen source, and then diesel fuel, and you can be in underwater as long as you have oxygen for your crew and food for your crew. So that's my only really experience of hydrogen peroxide. Okay, I think questions are thinning out and crowd is thinning out. Any more questions? Okay, yeah, you can. My handler here says that you're allowed to ask me afterwards as well.
All right, you guys, my name is Lauren Abbas, and I'm the Leader Speak Series Coordinator. I'd like to thank every one of you for coming tonight. If you have any more questions for Eva, she'll be here afterwards. So thanks again. If we can give a round of applause to Eva.